Good morning to all. Myself Dr. K. Manoran, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about types of machine learning. So the broadly machine learnings will be classified into supervised learning, unsupervised learning, reinforcement learning and semi-supervised learning. So supervised learning, so that will be used with the labeled data. Unsupervised learning, we don't have any labeled data. Reinforcement, so based on error, that will be trained. And semi-supervised, we are combining the supervised and unsupervised for a better results. So first thing we can see detailedly, first supervised learning, it learns from labeled data. So labeled data here is output will be taken as a label. So for each input, what is the output that will be given as a training data set. So that's why this is called as labeled data set. That labeled means that each input, what is the output that will be mapped for all training data. So that's why this is the labeled data. So only the training data that will be clearly know the output that will be used in a supervised learning. And for objective, it predicts an output from a new data. So the already we have a data that will be trained. Then if you have a new data that will be given as an input, and we will predict the output from the trained data. The common algorithms used in this will be linear regression, SVM, decision trees. So this is the sum of the algorithms that will be famous in a supervised learning. So the applications will be spam detection, disease diagnosis, image classification. This is the sum of the application for a supervised learning. Look at this. So here they are giving the things. So this is the system. We are going to predict this. What is the shapes? So this is supervised means whenever you are training the data, so each shape that will be trained with the output of that particular shapes. Look at this detailed example of this. So this is the labeled data and this is the label for this particular data. For example, look at this. So this is the carrot. So look at this. We have so many carrots. So we have a label for that will be carrot. Similarly, tomatoes. So we have a labels for that tomato. We have take as a tomato. Again, bell peppers. So this is the bell peppers. So we have a label for that. So these data, so labeled data with label that will be given for a model training. So clearly we know that. So for example, each data we know the output for a training models. So the training will be very easy and easily the model will be trained to get output because we each time give a data with an output. So automatically it will be easy for a trained data. So next will be prediction. So we are giving a test data. For example, here I am giving this carrot for this prediction. It try to identify it comes which classification. So we are taking these three classifications: carrot, bell pepper, and tomato. So if new data comes, so this will be mapped with the system and predicted which category this comes. So it will be classifying an example. Look at this unsupervised learning. So here this is the data is unlabeled data. That means we give a data for a training but without the outputs. So we don't know what is the output for that particular. So only thing is we need to discover the pattern and identify the objects. So this is need so many data to train, but this will be useful for a data we don't have an output means. For example, if we know the output for each data, then we can use a supervised. But if we don't know the output for each data, that best will be unsupervised learning. So the objective will be discover structure or a hidden pattern or hidden feature in the particular data sets. So the common algorithm famous in unsupervised K-means algorithm, PCA algorithm, hierarchical clustering algorithm. So the applications are customer segmentations, anomaly detections, dimensionality reduction. So these are the sum of the applications. Look at this. So this is an unlabeled data. So we are giving us so many things like a cat, dog, things, but we don't know the labels. What is the output? We won't give it. So this system completely identifies the patterns like a features like a color, objects, and eye places, and air places, or different legs. So many features will be available now. So that feature, hidden features that will be tried to identify. So based on that, whenever we give a new data, it will predict whether this is a cat or dog. So it requires so many data for a training. But this will be suitable for if you don't have then labeled data. So only possible is we need to use unsupervised learning. Look at the examples. We are giving a raw data. Look at this. So we have apples and oranges, but we don't give a labels for this. So we take this interpretation, and that will be given for the algorithm for predicting that, and we are processing that. So if you give a new data, it try to identify that whether it is an apple or orange with this system. Only thing we need more data for training the systems. Next will be reinforcement learning. So this is like an trial and error method. So whether this result is right or wrong, based on that the reward or punishments will be given that. So in this method the agent, so we use this environment to maximize the cumulative rewards. So we need to add some of this, both the rewards and punishment. So by this we can get the results. So whether we are improving or we have some improvement needed. So key elements are agents and then environment and reward, policies and value functions. Some of the applications will be robotics, game playing, autonomous driving. So these are some of the applications. Look at this system. So this is an environment, and this is the state, and this is the reward, and this is the action. So based on this, the action, the environment will be find. So these will be weightages. So the weightages will be fine-tuned to get the outputs. So whether the output is increasing or decreasing. So based on that errors, so that the weightages will be adjusted to get a correct results. Look at the examples. This is an raw input data we are giving to the system, and the system agents will be taken this, and based on this environmental things, the agent predicts it. So that will be given for an environment to fine tune this, update the weightages. So based on that, finally it will predict the different classification of outputs. And last one, this is the semi-supervised learning. So we are combining the small amount of labeled data and large amount of unlabeled data. For example, we don't have a labeled data, so we cannot use the unsupervised learning. Instead of that, a small amount of learned data will be given for the system easily trained. So it will be trained in a convergence will be possible in a very quick manner. So this will be useful when labeling is an expensive or a time consuming. So we have only limited data having labels. Or some cases where getting and labeled data that will be required more things, but there we use this semi-supervised. That means small portion of data have a labeled and large portion of data don't have a labels. So but still these data can be used to train the model and to predict the outputs. So it combines both supervised and unsupervised to give a results. It bridges the gap between supervised and unsupervised learning. So some of the applications for this will be medical image analysis, speech recognition, web content classifications. Thank you.